Hey everyone, Nitesh this side. Hope you are doing well. So let's start with the question. So the question is maximum width of binary tree. Okay. So you have given the root of the binary tree and you have to return the maximum width of a given tree. So maximum width of a tree is the maximum width among each levels. Okay. So in a tree you already know like there are so many levels. This is level 0, this is level 1, this is level 2. So you have to give the maximum width of each level. And the width is one level is defined as the length between the end node, the leftmost and the rightmost null node. So it basically from left node to the right node. Okay, and where the null node between the end nodes are also counted in the length calculation. So if you can see in this case, 2 has not left children, so this will also count in this. So for this case, if you calculate the width 1, 2, and 1 null and 1 this 9, so this will give you 4. Okay, so let's see with an example. Okay, so let's take this example. So this is given as node as 1. This left child is left, right child is 5, 2. Then the 5, and then we have 3, and then we have null, and then we have 9. Okay, so let's calculate the width of each level. So for this level, if you calculate for this, it will be 1. Okay, so this will be your level 0. For this case, if you calculate the width, so 1 node, 2 node. So basically you need to calculate from the left node, left basically from the left, and this will be your right node. So for this case it will be 2 and your level is 1. And if you calculate for this case, you need to check the leftmost node. So this is this. So you will point it here and you will point it here. So if you calculate the width between these, it will be 4. And this is your level 3. Okay, so you can see you got level, like for each level you got different width. You need to return the maximum width. So this case 4. Okay, so let's take this example also. This is your 1, 3, 2, and a 5, and all the right and children are null. Okay, so let's calculate the width for this. For this it will be 1. For this you are pointed here, you pointed here. So for this it will be 2. Now you need to calculate for this level. Okay, so for this level, if you see, you have a leftmost node, but you don't have a rightmost node, because if you can read in the problem statement, it is saying the width of one level is defined as the length between the end nodes, the left node and the rightmost non-null nodes. Okay, like in between there, like if it is having 6 here, it will be considerable, but if there is a right node which is null, then you can't take it. Okay, so for this case, if you calculate the width, it will be only 1, because you have only one node. Okay, so if we calculate the maximum width out of this, so this will give you 2 as output. Like in the width path, you can take null in between, but your rightmost node and your leftmost node will always be not null. Okay, so let's see how we can approach this question. Okay, so let's see how we can approach this question. So as you already know, we will go with level by level, so we can use BFS. Okay, so we will apply BFS. So what we will do, we will basically give the index for each left and right. Okay, so we will start from here and we will give the left index something and we will give the right index. Okay, so what will be the left index? Left index will be 2 into index plus 1, and your right will be 2 into index plus 2. Like this will help us to calculate the width. Okay, so let's calculate the left index. So for left, if you calculate, and your index will be always your parent index or your root index. Okay, so in this case your parent index is 0, so what you will do, 2 into 0 will give you 0, and you do 0 plus 1, it will give you 1. Similarly, if you calculate for this, it will be 2 into 0 plus 2, so it will give you 2. Okay, now let's calculate for this also. So for this case, it will be 2 into 1 plus 1. So this is 3. And if you calculate for this, it will be 2 into 2, basically 2 into 1, 2 into 1 plus 2. So for this case, it will be 4. We'll calculate for this case also. So this will be 5. And for this, it will be 6. Okay, so we got the indexes. Now how we will calculate the width? So we will calculate the width by like this. What we will do right minus left plus 1. Okay, so let's calculate the width for this. Okay, so we will check its basically if you compare for this, left is also this, right is also this. So for this, width equal to 0 minus 0 plus 1 equal to 1. Okay, now we will go only level wise. Okay, so this is one level. Okay, now we'll loop over this level, and we will only point out the first element of this level and only the last element of this level. Okay, so if you calculate the index for this, so it will be width equal to, like, your left will be your right will be 2, and for left will be minus 1 plus 1. Okay, so this will give you 2. Okay, so for this case you got a width as 2, and we take a max value also. So for till now this is 1, this is 2, so we'll update max with 2. Now let's take for this level. Okay, so what we will do, we will take the start index. So we will take the index for this, and we will take the last index. Okay, so for the last it will be 6, and for the beginning it will be 3. So 6 minus 3 plus 1, so it will be 3 plus 1, which is 4, and we will update our max by 4. So by this case we can calculate the width of any tree node. Now you will ask me, like, where we will store this node. So we have two options. Either we can take a map of basically node and that index, like it will be integer. So this we can take, or either we can create a new node of type, basically you can say a node and your index. Okay, so we can go with any approach. Okay, so let's write the code for this. Okay, so let's write the code for this. So for BFS, what we need, a queue. Okay, so we'll take a queue of tree node, queue equal to new linked list. Okay, now what we need, we will go with a map approach. Like, you can take the class approach also. So let's take map tree node and an integer. This will be equal to new hash map. So our first step will be, like, we'll insert all the element into, like, root element into the queue and map. So queue dot add your current node. You will also update your map by putting root and give the starting value as 0, because we'll start from 0. And let's take a maximum value, so which will be start from 1, because we inserted one root. Okay, so we'll loop over our queue. So while queue is not empty, we'll do something. Okay, so what we will do, we will loop over each level. Okay, so, like, we will insert all the element in the queue, and we will loop over each level. So first we will calculate the size of level queue, because in the queue at once only one level elements will be there. So queue dot size. Okay, we take two variables, like end equal to 0 and your start equal to 0. Now what we will do, we will loop over the size or the level loop size I plus plus. So what we will do, we will remove first element. Okay, so tree node remove q dot remove. Okay, now we need to update our end and start whenever we are at start of the level, or whenever we are at end of the level. So if your I is equal to 0, we'll update our start. How we will update it? So it will be let's take out the index also. So your current index will be map. You can get it from map dot get this index for this node. Okay, so start equal to index, and if I at last, basically size minus 1, I will update my end. So end will be idx. Okay, Now we need to insert your left element and right element into the queue. So if map dot, sorry, if your remove element dot left is not equal to null, we will insert it into the queue. Okay, we will insert queue dot add remove element dot left, and we will also update our map by pushing this current element map dot put remove dot element, and its index will be like, if it is for left, we will do 2 into index plus 1, so 2 into index plus 1, and if remove element dot right is not equal to null, we will do queue dot add remove dot right and map dot put remove one second, remove dot right 2 into idx plus 2. For this case we will do index plus 2. Okay, so after this loop, what we need to do, we need to update our map. Okay, sorry, you need to update your maximum. So you will calculate the maximum as maximum equal to math dot max, and you will calculate end minus start plus 1. After that you will return the max. Okay, let's run the code. So this is accepted. Let's submit it. So this is also accepted. Now the time complexity for this is like you will do for all the element. So it will, like, you will start from here. You can see we calculate the size and we are doing for every element. So for this, your time complexity will be order of n for each element, and you have taken the queue basically extra space. So for this, your space complexity will be big O of n. Hope you like it. Thank you for watching my video.